Welcome to this masterclass on embedded C programming. I warmly welcome you to the session. Thanks for coming and thank you for your time. And today is day 24. Only 6 more days to go. And today's topic is UART. Like yesterday, we have completed part of the code of UART using STM32F411 series. So today we'll be completing the rest of the code. Okay, and then I will explain the same code on how to use the header file which you could download from the ST website. Okay, and how to use the inbuilt header files and how to write the code. Okay, so this is from scratch. What we have done is we have written the code from scratch. So I'll also try to write the code using the header file which you could download from the ST website. Okay, and you could use it and you could write the code for UART. So before we go to the session in detail, I'll give a short introduction about Pantech and about me, and then we can go for the session. Okay, so Pantech, we basically manufacture microcontroller boards, DSP boards, and FPGA boards. We do also manufacture a lot of trainer kits for electronics as well as for electrical engineering. If you want to know more about our products and services, just log on to our website, pantechsolutions.net. Okay, our vision is to help 10 million students to learn the technology in an easy way. We have a lot of upcoming programs. We have upcoming program on IoT Masterclass for 30 days. It starts from next week. Okay, and we also have programs on self-driving car and software-defined radio, as well as digital signal processing and brain computer interface. Okay, so please do stay connected on our channel. Please subscribe to the channel so that you get notifications whenever we post a new program. Okay. About me, my name is Jeevarajan. If you want to connect with me, I have my LinkedIn link in the description. You could send me a connection request. I'm happy to connect. I'm happy to help. If you want any kind of support, or if you want any help, or if you want any clarifications, just send me a message on LinkedIn. I'll be replying within 24 hours. Okay, I'll send the reply within 24 hours. So coming to the announcement, attendance link will be available at 9 p.m. So minimum attendance required to get a free e-certificate is 25 days. Okay. For the internship candidates, no need to fill the attendance form. All you have to do is, after watching the video on the portal, just give complete and continue on the top. So that will mark the attendance. PPT will be shared in Facebook group and as well as in Telegram group. Source codes and projects are available only for the paid participants. You could download from the portal. We have the internship for the combo internship for this course, Embedded C and Embedded System Design and IoT Masterclass. So the cost is 999 rupees. Okay, you'll get access to the course for 1 year, and you get access to the hackathon. You get access to the intensive session, which is for 8 hours on Zoom platform. So if you want to enroll, you could enroll the internship and avail more benefits. Okay, so let's start the day with the mindset lesson. So today mindset lesson is about, if you can see it in your mind, you can hold it in your hand. So this sentence is from Bob Proctor. Okay, if you can see it in your mind, you can hold it in your hand. Whatever the mind can conceive and believe, it can be achieved. Okay, so that's a point. And the second lesson is about, don't believe your doubts and don't doubt your belief. Okay, in order to have success, the first key essential component is belief. Okay, you have to believe on your goal and you have to succeed. So believe and succeed. So these are the lessons I'd like to share you today. I hope it's useful for you. Let's go for the session. Okay, if you are ready to learn, just type RTL in the chat box. So I'll open the program. Okay, so this is the program which we have completed yesterday. I'll give you a short overview of the extended programs. Okay, so we have created a project, and we have initialized the pointers for the registers. Okay, for AHB1 ENR for the RCC registers and the APP peripherals. Okay, so our USART2, we are going to print the value on USART. So USART2 is connected to APP bus. So we have to enable this APP bus. We have to enable the clock for this APP bus. For that, we have initialized the address by using the memory map registers. Okay, and port A, this is USART2 is available on port A as a alternate function. So you need to enable the port A also. So for you have to initialize the clock for port A. Port A is connected to AHB1, like AHB1 bus. So you have to enable this AHB1 ENR also. And the mode registers. Mode register, we have to configure the GPIO A mode for the alternate function, because USART is an alternate function. So we need to configure the mode registers. And alternate function like low and high, there are two registers like AFRL L and AFRL high. Okay, so PA2, like USART2 is available on PA2 and PA2 and PA3. Okay, PA2 is the transmitting and PA3 is receiving. So you have to configure the alternate function registers. So for that we have initialized, and the USART registers like data registers, okay, and baud rate registers and control registers. So we have initialized the registers value by using the you could directly get those values from the data sheets, or you could use the SFR registers. Okay, so I built the project. Okay, so we have created a function like for initialization function, where we have enabled the clock access to the GPIO A. First, we have to enable the clock access for GPIO A, and A2 mode, PA2 mode, we have set the alternate functions. Okay, as per the data sheet, like we have to set 10, okay, 10 on the registered GPIO mode A, or GPIO for setting the, like, clear this value and set this value. Okay, set this value. Let me open the data sheet. Okay, so these are the alternate function register, like where we have to set AF7 011. Okay, 011. It is available at 2, AFRL2 and AFRL3. So AFRL2 is for transmit. So we have to set 0111 here. Okay, 011 here. Okay, so we have set this value like 0111 for AFRL, and mode register we have configured, and we have enabled the APP1 ENR. Okay, UART2 we have enabled, and we have to load the baud rate at this BR baud rate register. So for that we write a simple function to calculate the UART baud registers. Like we have configured the baud rate as 1,15,200. Okay, yesterday, like, we have configured 1,15,000. You could also change it to 9,600. First I'll check for 1,15,200. Later we can change for 9,600 baud rate. Okay, so we have completed the code till this. So the next part is, okay, we have completed the code till this. So next part, let us we have completed the baud rate, we have initialized the baud rate. So we have to configure the transfer direction. Okay, the next thing is we have completed till this point. Okay, so configure the transfer direction. The next thing is configure the transfer direction. So if you click USART registers, you have, these are the USART registers available, the status registers. Okay, and we have SR is for status registers. Data register, we have USOT underscore DR is the data register. Okay, BRR is the baud rate register, and control register is CR1. Okay. So we have to enable this transmit enable one. A third pin. Third pin, we need to enable this third pin. Okay. So it's 8. We have to move. So USOT underscore CR1. USOT underscore CR1. We have to enable this TE. So uh, TE is transmitter enable. Okay. So TE is transmitter enable and receiver enable is bit 2. So as of now, I'm going to enable only the transmitter. So I copy this USOT underscore CR1. Okay, it's 2 USOT underscore CR1. So we have already declared here like USOT 2 underscore CR1. Okay, I just copy this. We have to okay 008. So we have enabled transmit enable. Okay. So the next position, again, we need to, once we enable transmit, like we should also enable the in USOT C1, like we have to enable transmit and okay, USOT enable. Bit 13 we need to enable this UE. Okay, USOT enable. We also we need when the bit is UE pin should also be enabled. So let me calculate. Okay. So we need to enable UE also. So I just take this and you have to, it is done intentionally for the next statement. So you have to enable it first and then you have to make it on. Okay. You could write this 2 line on the same code, but it's advised to done as a separate statement. So we have configured the transfer directions. Now let's write a function for UART. Right. Okay. So I just copy this. Okay. And int ch. So while off, make sure the transmit data register is empty. Okay. So in order to make sure that transmit data register, it's SR register. Have to check whether it is empty. Okay. So if you and with this value, like you can check whether it is empty. If it is not empty, then you can you can write to the data register. Okay, you copy this data register. Okay, so let me build this project. Let me check for errors. Okay, there's no error. So now let's go for the main program and create a simple while loop. So you just define the prototype on the top. So I will pass A. Okay. Build the project. So let me check once. It should work. So we have create a function to write the data. Okay. So you have to make sure the transmit data register is empty. Then you have to write data to the data register. Okay. So here you check. Okay. And write transmit data register. Okay. Build the project. Debug us. Okay. So I just open the device manager. So I'll run instead of debug, I'll just download the program. Right click, run as straight line, just run the application. Okay. So check for the COM port. The COM port is 6. Okay. So I have connected to kit to this COM6. So I just open Arduino IDE, go for just any serial viewer. Okay, you can use any serial viewer, like I use serial monitor just for visualization. I set the baud rate, clear output. Okay. Let me open real term, like I have one more real term. Okay. I have one more serial viewer, like choose port 0, choose COM6 here, click open. This is 1,15,200. And let me check. So we have some problem. Let me check. Let me check the code. Okay. Let me cross check the registers. So first we will check the UART registers. UART 2, we are using UART 2. So SR is 04, it is 0400, okay. And DR is also 044404. And BRR is also, it's wrong, okay, it's wrong. And CR1 is also wrong, okay. So the memory map is wrong. So now I have corrected this memory map. Let me check for the other RCC also, okay. Let me check for RCC. Is AHB1ENR is 040280, it's right. 3830, okay, it's right. And APP1ENR is 3840, it's right. Okay. Mode R register GPIOA, like. So if you make any error on this memory map, then it won't work. So please ensure that values are right. Okay. F for all. Okay, so let us build the program again, build the project, or right click, go for run as STM32. Okay, so I'll open the serial monitor, real term. Okay, choose the port. It is connected to COM6. Click open. Okay, and the baud rate, like we have chosen the wrong baud rate, 1,15,200. Click open it again. Let me clear and open again. Okay. Okay, now you could see the value A is getting printed now. So we are getting the output on the UART. So let me cross check and verify once, and let's check again. Okay, I close this one. Let me try B now. I am going to transmit B. Right click, build the project, and right click, run as STM32 in Cortex application. Okay. So okay, now let us check. So it should display B now. Okay, click open, clear this window. Okay, let me reset. Okay, so it's printing B now. Okay, so it's working fine. So I will explain the code one more time, and then we will go for how to use printf in UART. Okay, so we have defined the system frequency. Like this is the system frequency is nothing but 16 megahertz. We are using the nuclear board. The nuclear board is using 16 megahertz. So that's the AP1 clock frequency. And UART baud rate is, the desired baud rate is 1,15,200. So if you want 9,600 baud rate, you change this 9,600 baud rate and you build the project again. Right click and you run as STM32 Cortex application. You change the baud rate now, like to stop this. Okay, clear this one, change the baud rate to 9,600. Once here it is done, and click open now, it's printing at 9,600 baud rate now. Okay, so if you change 1,10,200, click open. Okay, it won't come. So this is the 1,15,200 baud rate. So you have to change 9,600 baud rate to get the right output. Okay. Open, click. Okay. So this is the 9,600 baud rate. So you can choose a baud rate here. So these are all the memory map. So you have for the registers, like you have to correct the right number. So we have given the wrong number. So that's the reason, like initially it was not working. So first thing is you have to initialize UART. Okay, to initialize UART, you have to enable the clock access for the GPIO, because UART pin is available on the GPIO A. It is connected on port A. So we have enabled port A, clock access for port A, and we have to configure the alternate function mode 10. We have to set 10 for PA2. Okay, and alternate function type we have to configure. It is 0111. Okay, 111. So we have to configure on alternate function registers, and we have to enable the UART2 on the advanced peripheral bus, and like we are loading the baud rate, desired baud rate to the register, BRR register. Okay, to calculate the formula is here, like peripheral clock plus baud rate divided by 2. U stands for unsigned, and divided by the whole divided by baud rate. Okay, or you could also do the calculation and directly load the hex value. This is for 9,600 baud rate. and you have to configure the transfer direction. You have to enable transmit enable, okay, as well as UART enable. So we have on the control register, okay, we have done this, and UART write, you have to make sure that you have to wait until the transmit data register is empty. Once it is empty, then you could move the value, whatever the value which you want to print, you could move the value. Okay, so this is the code for UART. Now I will configure with the printf. Okay, so earlier like we have configured the printf with the serial wire view, right? So this time like we will configure printf with UART. So what I right click, I just copy this project, right click, copy, and right click paste. Okay, so this is UART underscore printf. Okay, I'm going to use UART printf. Close this code, click main.c. Okay, so in syscalls.c, like you have a function called this IO put underscore char. Okay, you copy this, like on right, it will be on right, like right function. Okay, so copy this and you declare here. Okay, so int of okay, so here you just copy this function UART write of ch. Okay, so you have to return ch. Okay, so now you could I'm just going to comment this line, and I use printf hello world. Okay, I just type printf hello world /n/ okay, so now right click, build the project, and right click, debug as STM32 Cortex application. Choose your printf.elf, click OK, and click OK. So now if you try to open the serial port, I'll show you that on Arduino, like I will use Arduino now. Like you could also use Arduino for serial view to visualize the serial monitor. Okay, I just choose the COM port as COM6 and tools open serial monitor. Okay, so this is the monitor. So we are at 1,15,200 baud rate. So I just reset its B. So we have only the old value until now. Okay, we have only the old value. Let me reload the program, run as STM32. So UART printf.elf, click OK. Okay, so program is done. Let me check. So I'll check with the baud rate. The baud rate is 9,600. Okay, so we have given us 1,15,200. So let me change the baud rate. So it prints hello world now, right? Hello world. So you can integrate printf with this serial port. So you have to include this piece of code. Int of this, you copy this function from the syscalls.c. and int ch, pass the character what you want to print. You are to write, okay, return ch. Okay, so this is the program. Okay, instead of UART underscore, right, like I have used printf now. So, and it is printing on the serial port. Okay, it is printing on the serial port. You could use serial port to communicate with the Wi-Fi module to, or with the Bluetooth module. So the application use case is a lot. Okay, so I just explain the code one more time. Like here we have add this piece of code. Okay, this piece of code, you are to underscore write and return ch. Okay, and we have used printf. Okay, so the next like how to write drivers, like how to write a professional course for UART. Like I just copy this, right click, copy, okay, right click and paste. So I'm going to create two files. Okay, I choose this UART printf. I'm going to file new C source file, new C source file, UART.c. I'm going to give the file as UART.c. Okay, the other file as UART.h. Okay, UART.h. Okay, so we have created UART.c and UART.h here. So click the main function here. Okay, I'll close the previous program. Click the main function here. Okay, and you would see, I just drag like this, and once the changes, cursor changes, I just leave it out. Okay, so you will get two views. So I'm going to copy all the header file component to the header files. Okay, so all the declarations like the hash define, so these things, I just copy this from main file to I'll cut this main file, and inside this include quotes, I just include this one. I also need to copy this std.h. Okay, all the prototype definitions I have moved to the header file, and all the functions. Okay, all the functions, I just cut this functions and I move to UART.c. Okay, here you need to include this hash include math.h. Okay, we have to use double quotes because we have that's a user defined header file. Sorry, it's not math, it's UART.h. UART.h. Okay, now save the program. Let me check once. Okay, so let me compile the program now, like build the project. Let me check for errors. So now we have organized as UART.c and UART.h, whereas in main.c, so this is the code which we have in main.c. Okay. So right click, build the project. I'll change the border to 1,15,200. Okay, 1,15,200. Build the project again and right click. Run as STM32 application. Okay, have to choose this ELF. Click OK. So if you check in the serial window, like this is the window, like I need to change the border now 1,15,200. Okay, so clear output. So the code is working fine. Okay, so I have organized the code, like I have converted this UART.c and UART.h, okay, and main.c. So main.c, so all the driver files, for example, if you're going to use GPIO, like GPIO I2C, you create I2C dot I2C C.c, I2C.h, okay, is spy.c, spy.h for spy protocol. For USOT, you could use USOT.c and USOT.h. Okay, so you can organize in this way. So in tomorrow's session, like we will be covering up the same UART, but we are not going to use any one of, like the way we are going to code is different. Okay, so we are not going to define like we are not going to define any memory map. So I'm going to use the file from the ST website. I'm going to download the header file from the ST website, and I'm going to use structures. Okay, I'm going to use here we have used pointers, but tomorrow class will be using structures to store that. Okay, structures to store that. So like Sunday we'll be having classes for 2 days. Okay, so I'll cover up sessions. The session Sunday we will be having a class for 2 hours, for 1.5 hours, which will cover up 2 days. Okay, so that will be on time, and we'll be closing the 30-day series within Tuesday. Okay, so thank you so much for your time. So you could try this one. So we have internship for 999 rupees. The combo course ends on this. The internship ends on this on this session, like within the Tuesday till end. So if you want to enroll, like you could enroll. Thank you so much for your time. See you in the next session. Until then, bye bye. Take care.